Okay, logs and indices is a difficult topic, and I can guarantee you this is probably the part of algebra and fifth year maths in general that I hated the most, and it comes up in your leaving cert in section A and section B year after year. So we're going to run through some basic stuff here. This will really, really help your maths. This one here is an indices question. You want to bring like solve for x. You'd probably need to keep in mind you want something like 3x is equal to 3 to the power something. So what's 81? What's 81? Like 3 to the power what? What's 81? 3 to the power what? 3 to the power 4. That's what it is. That's an easy one. So x is equal to 4. Bing. That's it. There you go. Okay. So that's the first one done. And this one is a simple log question. So if we run through this, right, what would you do here? Like when I think of logs, I'm always thinking that like I gotta get rid of the log. I gotta get rid of this. So I'm thinking this pushes up this fella. It's just the way I think about it. Like it pushes up the other one because you can't work with logs. You got to get rid of the log. So if you work my logic, the 8 will push up the 2. The 8 would push up the 2. So it ends up becoming 4x minus 1 is equal to 8. And I'll show you the different color if you want, to the power 2. That's what the log does. And then the log is gone. Does that make sense? That is like logs 101. That's what it does. It just pushes up the other one. It's the way I think about it. And if you do that and you work it out, it's easy. So if you want to keep going, 4x minus 1 is equal to what's 8 squared? It's 64. 4x is equal to, bring that 1 over, obviously. Can't be having that. 64 plus 1. Yeah. So 4x is equal to 65. 65. And that ends up being, if you put it into your calculator, x is equal to 16.25. That's what it ends up being in the end. And that is a basic log question. Okay. Now the next one. So, this one is a bit trickier, right? And you will need to understand logs and log rules a bit more here, okay? Now, like what I would talk to you about here really is like this is what I hone in on firstly. So I bring them on to one side if you want, but I'll focus on this one first. Like you want to get rid of the 2. See the 2 before the log? See that 2 log? That 2 log 4? We want to get rid of that 2. 4x minus 9. We want to get rid of that 2. We really do. So we want to get rid of that 2. So how are we going to get rid of that 2? How are we going to get rid of that 2? Because you want like, this is log 4 and you want this to be just log 4 as well, no 2 attached. That's the whole point, right? So to get rid of it, you can use your log rules. You can bring this up to here. So it's the same thing as saying log, and it's just log rules, log 4x minus 9 to the power 2. And that to be squared essentially. So now you essentially have, right? If you look on both sides of the coin, I'll make my face a small bit smaller here to help. Now essentially on both sides of the coin you have what? Log 4 2x plus 3 is now equal to log 4x minus 9, 4x minus 9, all to be squared. And see, this is where the magic kicks in. You're going to get rid of your logs. I spoke with that. That's log 4. That's log 4. And so you can just say now that 2x plus 3 is equal to 4x minus 9, all to be squared. And you work it out. That makes sense. And if you understand that part, that's the key part of the question. That's a 3 there. It looks like an alien. That's the 3. That's if you understand that far, then that's the part of the question. That's the key part. That makes sense. That's core. If you get that far, you've won. The last part is just using the minus b formula and a quadratic. Like you literally just, all you got to do then after this is just multiply it out. And you get a quadratic. And then you use the minus b formula to figure out exactly what the value of x is here. And it comes out as being 3, by the way. I won't do it now because it'll take ages. But you just multiply this out. Literally multiply this out. Square it out. Square this out. Multiply it out. Bring it together. And you should end up getting something like 8x squared something. I won't do it now. The answer ends up being 3. You can finish it off. But that's just to show you. Makes sense. That's just basic. And that's just basic. Not basic. That's a difficult log question. Now this question here on indices. Can you have a look at this and try it? Look at it. You can give this a go. It's not that difficult. You just need to like work with indices or indices, same thing. All right. So like you gotta bring it all down to 3. That's the first thing you gotta do here is bring it to 3, because you can see there's a 3 to the power 2x plus 1, and that's going to be your base. Like, so you got to bring it all to 3. So like what's 27 the same as? 3 to the power what? What's 27 the same as? It's 3 cubed. So you could say 27 for x, which is here outside. That's 20. That's that part done, is equal to what's 9? 9 is 3 squared. So now they can talk because it's all the same base 3. Yeah. And then you gotta work from here. It's easy enough. Like, but then this is a bit, I miss this part. Like, this has been divided, isn't it? See, that's a division. Like, that's a fraction, so it's been divided. So you're dividing powers. You take them, don't you? So it ends up becoming 3 to the power 2x plus 1. Take, because this 3 by x gives me 3x. Take 3x. Does that make sense? Is equal to 3 squared. Does that make sense? That's the crucial part. Because they're being divided, essentially, dividing powers, you take them, minus 3x, and 3 by x gives me 3x. That's where it comes from. Does that make sense? And you just finish it off from here. 3, what's 2x take 3x is just minus x. So 1 take x is equal to 3 squared, and you can finish it off. Just keep your powers now together. So 1 take x is equal to 2. Minus x is equal to 2 minus 1. Take 1, so it ends up being 1. So x is equal to what? Minus 1? Yep. Answer. Makes sense? Now, this is a harder log question again, and probably like has a lot going on here. You might get confused, but we'll work through this. First thing you do is, you're adding logs, you can multiply them. Just like going in and out. If you're multiplying logs, you can add them. If you're adding logs, you can multiply them. If you're dividing logs, you take them. If you're taking logs, you can divide them. Just over and back the whole time. Just work it. Ultimately, you're simplifying down to find x. Does that make sense? That's what we're trying to do. So let's try this one here. So we're adding logs so we can multiply them. So it ends up being, because they're the same base as well. See the 3. That's why. So it ends up being log 3 by x plus 1 by x squared x squared plus 2x plus 2x and plus 1. All right. And you'll notice something very interesting here. This. What is that same as saying? Think about what if you were to simplify that down, you should know this. Like, this is the same thing as saying, if you spot this, the same thing as saying x plus 1 all to be squared. Isn't it? If you look at it now, it is. So now you have x plus 1 log base 3 x plus 1 is equal to 3. Now it's getting interesting. And look, if you combine these, then see, they're the same thing. So the same thing is saying log base 3 is equal to x plus 1 all to be cubed is equal to 3. Now, this is interesting again. You can use your more log rules, because this is probably killing you here. Well, you mightn't spot this, but you probably should be thinking, oh, I can just bring this in front. You could. You really could. If you did, you're winning. Because then you bring it in front, and it ends up being log 3 x plus 1 is equal to 3. And you're thinking, oh, now we can actually just knock off the 3, because there's 3 on either side. Goner? Goner just gives me 1, right? To divide by 3 at both sides. So now you're left with this thing that's log 3 x plus 1 is equal to 1. And if I asked you to solve that, what would you do? The last step now. What would you do? Last step now. Remember, I always say it pushes this up here. So it pushes that one up there. So it ends up becoming x plus 1 is equal to 3 to the power 1. And so it's just 3. And so, it ends up being x is equal to 3. Bring the 1 over, becomes minus x is equal to 2. Because you're going to bring the 1 over, it become minus. So 3 take 1 is 2. That's your answer. There's a lot going on there, but it's just you used log rules twice in the one question, which is probably not what you usually expect, but that's a lovely practice one now. Last one here.